Ya, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning all. Good morning, Mr. Afido. So thank you for giving us the opportunity to present today. Okay, we are from group 5, consisting of Putri, Sakinah, Azzahra, Datin, Hasma, and myself, Fadhlyatul Nursiva, who was the moderator. Okay, here we will present a material entitled Incentive for Chemical Process Control. Okay. Next. A chemical plant is an arrangement of processing unit, reactors, heat exchanger, pump, distillation column, absorber, evaporators, tank, etc. integrated with one another in a systematic and rational manner. During its operation, a chemical plant must satisfy several requirements imposed by its designer and the general technical, economic, and social conditions in the presence of ever-changing external influence disturbance. Among such requirements are the following. Next. For the number 1 is safety, and number 2 is production specification, and number 3 environmental regulation, number 4 is operational constraint, and for the last one is economic. Okay, next.
First, safety. The safe operation of chemical process is a primary requirement for the well-being of the people in the plant and for its contribution to the economic development. Thus, the operating pressures, temperatures, concentration of chemicals, and so on should always be within allowable limits. For example, if a reactor has been designed to operate at a pressure up to 106, we shall have a control system that will maintain the pressure below this value. As another example, we shall try to avoid the development of mixtures during the operation of plane. 2. Production specification. A plane should produce the desired amounts and quality of the final products. For example, we may require the production of 2 million pounds of ethylene per day of 99.5% purity. Therefore, a control system is needed to ensure that the production level 2 million pounds per day and the purity specification 99.500 ethylene are satisfied.
And the third is
and for the number 3.
Number 3 is environmental regulation. Various federal and state laws may specify that the temperature, concentration of chemicals, and flow rates of the effluents from a plant be within certain limits. Such regulation exists, for example, on the amount of SO2 that a plant can eject to the atmosphere, and on the quality of water returned to a river or a lake. And the fourth is operational constraints. The various types of equipment used in a chemical plant have constraints inherent to their operation. Such constraints should not be satisfied throughout the operation of a plant.
Okay, for the last one Economic. The operation of a plant must conform with the market condition, that is, the viability of raw materials and the demand of the final product. Furthermore, it should be economical as possible. It is a utilization of raw materials, energy, capital, and human labor. This is required the operating conditions are controlled at a given optimum levels of minimum operating costs, maximum profit, and so on. Okay, next. All the requirements list above dictate the need for continuous monitoring of the operation of a chemical plant and external intervention control to guarantee the satisfaction of the operational objective. This is a complies to a rational arrangement of equipment, measuring device, valve, controllers, computer, and human intervention, plant designer, plant operators, which together constitute the control system. Okay, next.
There are three general classes of needs that a control system is called on to satisfy. First is separating the influence of external disturbance. Second, ensuring the stability of a chemical process. And third, optimizing the performance of a chemical process. First, suppressing the influence of external disturbance. Suppressing the influence of external disturbance on a process is the most common objective or a controller in a chemical plant. Such disturbance, which denote the effect that the surroundings external world have a rector, separator, is a changer, compressor, and so on, are usually out of the reach of the human operator. Consequently, we need to introduce a control mechanism that will make the proper chance on the process to cancel the negative impact that such disturbance may have on the desired operation of a chemical plant. The example is controlling the operation of a stirred fan heater.
The next is ensuring the stability of a chemical process. Sometimes we would like to operate the CSTR at the middle unstable steady state for the following reason. One is the low temperature steady state because very low yields because the temperature is very low. And the second is the the high temperature is very steady state may be very high because unsafe condition, destroying the catalyst for a catalytic reactor, degrading the product, and so on. So in this case, a controller that will ensure the stability of the operation at the middle steady state is needed.
Okay, for the last one, optimizing the performance of a chemical process. Safety and the satisfaction of production specification are the two principal operational objectives for a chemical plant. One, when these are achieved, the next goal is how to make the operation of the plant more profitable, given the fact that the conditions which affect the operational of the plant do not remain the same. It is clear that we would like to be able to change the operational of the plant, flow rate, pressure, concentration, and temperatures in such a way that an economic objective like a profit is always maximized. This task is undertaken by the automatic controller of the plant and its human operators. Example, optimizing the performance of a batch reactor. Okay. Um, Next. Thank you for attention. If you have some question, you you would like to write in comment. Yeah. Okay.